Hi everyone. In this video clip, I'm going to discuss about the difference between Apache Flink, Apache Spark, and Apache Kafka. Three of these are the open source products available in the market. Let us see the difference between them. All these technologies are related to data processing. When it comes to data processing, the journey of the data pipeline begins with picking the data from the data source. And once the data is picked from the data source, it will undergo processing. We also call transformation of the data. And under this umbrella of processing and transformation, different things will come into picture, and that's very vast area. And once the processing is done, again the processed data is returned to one location, which is called as a sink. So in essence, the data pipeline will be consisting of the source, the processing component, and the sink. With this background, let us now try to get the difference between Apache Flink, Spark, and Kafka. Apache Flink and Kafka, they fall under, they're closely integrated. And let us, before going to the maybe differences, let us try to check here who are the enterprise grade vendors for these technologies. For Apache Kafka, we have Confluent, and recently Confluent has acquired Flink as well. So enterprise grade solution for Kafka and Flink is provided by Confluent. Enterprise grade enterprise grade provider for the Spark is Databricks. Fine. Let us first look at Apache Spark. Apache Spark, main purpose of it being doing the batch processing of the data. So in bulk, we will be loading the data into the pipeline, and it is good at processing that data. But then Spark also has, to great extent, stream processing capabilities as well. But then, originally, Spark is designed to be working with the batch data. As a special case of working with the batch data, it deals with the stream data by using the processing model called micro batching model. So, because of this reason, in comparison to the Flink, Spark gives higher latencies when it comes to working with stream processing of the data. With respect to these points, if we look at how does the Flink process the data, originally Flink is designed to be working with the streaming data, but then as a special case, Flink can also deal with batch data. So truly it is a streaming data processing engine, but as a special case, it can process the batch data. That's where we see here the processing for the model for the Flink is truly streaming, but when it comes to Spark, it is micro batching based processing model it will be using for processing the streaming data. Fine. What are other things that we have here? Um, when it comes to working with the streaming data, the concept of state comes into picture. When we take that state into consideration, Flink offers excellent uh, control and I could say, right, uh, capabilities to deal with state management in comparison to Spark. Coming to the fault tolerance aspect of Flink and Spark, both are good. Uh, Spark achieves fault tolerance through its RDD lineage and checkpointing concept, and Flink achieves fault tolerance to the checkpoints and save points concept. In due time, I will be launching uh, codes on Flink and Spark. There, I will be talking about what's the difference between checkpoint, save point, and of course, lot more things. Fine. Likewise, when it comes to processing the data, a windowing concept is also very important, and Flink offers to greater extent the window-based data processing capabilities. Very advanced one in comparison to Spark. So that way, uh, with this kind of architectural differences between the Flink and the Spark, when we consider the use cases for the Flink, it is a real-time analytics and fraud detection. It is very good at doing the CEP, complex event processing, and it gives a framework to deal with as well. When it comes to Spark, its use cases include processing of the batch data, doing the ETL implementation of your pipelines, and it has good support for machine learning related things, and it has Spark structure streaming and all for processing the streaming data. Fine. Let us now look at the ecosystem of the tools provided by the Flink. It is on the fast track. Okay, in its arms, it is getting more number of tools. Okay, with it, uh, its Flink machine learning related libraries are yet to get more extensions, and its graph data processing also it is not widely adopted, but it is widely well known for its streaming data processing through its Flink CEP libraries. But when it comes to Spark, it has well matured ecosystem. Okay, it gives us uh, libraries to work with structured data, unstructured data, semi-structured data, and it gives machine learning libraries, which is quite matured and widely used. And it also gives us a graphics module to work with the graph database. Fine. Looking at the kind of maybe languages that one should be using to work with the Flink and Spark, uh, you can work with Flink using SQL, that is through the Flink SQL, or you can work with Flink using Table API. Either Python we can use, Java we can use, or Scala we can use it. When it comes to Spark, uh, we can work with or program with Spark using SQL for sure, which is called Spark SQL. Next, we have Python, and we have Java and Scala. Most likely, the wider adoption among the data engineering is Python-based Spark programming, which is nothing but PySpark. Fine. So, in general, if we try to broadly look at it, uh, main focus of Flink is at dealing with the real-time uh, streaming data processing. Spark, it's about general purpose data processing, which also includes streaming data processing as well. So that way, when I'm speaking about Flink and the Spark, we have been I have been speaking about data processing part of it. The other thing that we are trying to bring in here to compare against is the Apache Kafka. Let us see what is that Apache Kafka. Apache Kafka originally is a message broker system. What's the meaning of it? It can reliably deliver data from point A to point B. Okay, and it has evolved to be very robust message brokerage system, and today it is very reliable distributed streaming data platform, which is implemented using the pub-sub architecture, publish subscribe messaging architecture. It gives very high throughput and very low level of latency when it comes to delivering data between the sources and the sinks. Okay, primary focus of it being the message brokerage, and it does bit of the state management and all for retaining the messages, and it is very highly fault tolerant by okay replicating the data. Okay, Kafka stores data in the form of the topics, which are further divided into partitions, and partitions are replicated, uh, which gives Kafka the fault tolerance feature. Kafka being the distributed streaming platform, it also gives us libraries to do in place uh, data processing capabilities. Fine. It gives us one library called Kafka Streams, which provides much bit similar to Spark and Flink, the streaming data processing capabilities. Using Kafka, we can build real-time data pipelines, message queuing systems, and it acts as storage for the streaming data. It is quite matured and widely used. Okay, it has Kafka Connect libraries, Kafka Streams libraries, and so on. It gives us KSQL, uh, the SQL flavor to work with the data present in Kafka cluster. Fine. So, in essence, the focus of Apache Kafka is being streaming the data across the required sources and the sinks. So, so in this video, we have seen the overview of difference between Apache Flink, Spark, and Kafka. In the upcoming videos, we will discuss in depth about each of these topics. Thank you. Stay tuned.